This is a story about a tool so ordinary now that we forget it had to be invented. You use it every day, you probably learned it grudgingly, and it began as an emergency written by one person in about 2 weeks. Let me try to make you see it the way its admirers do. In April 2005, the Linux kernel had a problem that money could not fix. For 3 years, it had relied on a commercial system called BitKeeper, offered free to open source out of goodwill. That goodwill broke down, and the free license was withdrawn. The largest collaborative software project on Earth suddenly had nowhere to keep its history and no free tool fast enough to take over. So Linus Torvalds sat down and wrote his own. He started on April 3rd. 4 days later, on April 7th, the thing was already storing its own source code, tracking the very edits that were building it. Within about 2 weeks, it was usable for the kernel. By June, it was managing the kernel's official release, not a product, a rescue that happened to be beautiful. Here is the bet at the center of it. Every system before Git recorded changes, the edits you made, and trusted a server to keep them straight. Git refused that. It decided to store content itself, whole and unaltered, and to give every piece of content a name computed directly from its bytes. Store the thing. Let the math remember it. There are only four kinds of thing inside a repository: a blob, which is the contents of a file; a tree, which is a listing of a directory; a commit, which is a snapshot with an author and a message; and a tag, a friendly name for one of them. Each object is run through a hash and named by the result. Change the contents and you change the name. The name is not a label you assign, it is a fact about what is inside. Now watch what that buys you. A commit's name is computed partly from its parent's name, which was computed from its parent all the way back. It is a chain where every link is sealed by the one before it. Alter a single byte in some old commit, and its name changes, and so does every name that descended from it. You do not have to trust that history is intact. You can check it. And Git does not think in differences. It does not keep a stack of edits you have to replay to know where you are. Each commit points to a complete snapshot of the whole project. Because everything is named by content, two versions that share an unchanged file simply point at the same object, full pictures, and nothing identical is ever stored twice. Day to day, you live between three spaces: your working directory, where you edit; the staging area, sometimes called the index, where you gather what you are about to save; and the repository, the committed history. That is all the everyday commands really are. Add moves work into staging, commit records staging into history, checkout restores history back into your working files, three trees, and a few moves between them. Because a commit has a name, a branch can be almost nothing. A branch is a tiny file that holds one hash. Making a new one costs nothing. Moving it forward is rewriting one line. Once branching is that cheap, the fear drains out of it. You stop guarding a fragile main copy and start trying things because an experiment is free and throwing it away costs you nothing. And there is no center. When you clone a project, you do not borrow a working copy from a server. You receive the entire repository, every object, all of its history, onto your own machine. Everyone holds a full, equal copy. There is no single place that, if it fails, takes the project down with it. The kernel that lost its server in 2005 would never depend on one again. Underneath, Git is honest about being a toolkit. The friendly commands you know are called porcelain. They are a thin layer over a smaller set of blunt, precise primitives called plumbing. Verbs that store a blob, record a tree, seal a commit. The polished command you type is just those primitives composed. You can reach past the surface anytime because the surface was built out of parts you are allowed to touch. This is the thing worth admiring. Not a long list of features, but a very small core. Content named by its hash, four object types, a chain that seals itself. Everything else, branching, merging, distribution, the whole cooperative sprawl of modern software is composition on top of that core, not more machinery underneath it. Small, careful primitives producing capability far out of proportion to their size. 20 years later, more than 9 in 10 developers build on it. Not because it is easy, it is often not, but because that small idea turned out to be the right one. Your code reviews, your pipelines, your deployments, the platforms whole companies are built around, all of them sit on the object model one person sketched in a fortnight to get himself out of a bind. The kernel that lost its ground now stands, along with almost everyone else who writes software, on something it can verify to the byte. That is the quiet marvel of Git. History you do not have to trust because you can check it, named by content, and built without anyone intending it to outlast its author. If you enjoyed this video, drop a like and subscribe. And tell me in the comments what you want me to explain next.